You've seen the video on confidence intervals and on the overview for what we're doing for section 8.1 in particular. In chapter 8, we're going to be looking at this idea of estimating values given some information. So just some overview of some terminology. We have a population, which is the set of all of the things that we're going to be measuring. So the population is the total set. And if we take measurements from that set, we get a parameter. And if we take not the entire population, but just a subset, a sample, those measurements give us statistics. So for example, the top row, if you're looking at the mean of a sample, you get X bar. The mean of the whole population we call mu. So we have seen these first three. Proportion, we'll look at that in section 8.3 later. So the idea here is we're going to use statistics, for example X bar, to make inferences about parameters, for example mu. So right now in section 8.1 we're going to see how we can use X bar to tell us something about mu. So we're going to be taking two kinds of inferences. We're going to use the values that were given to estimate values of population parameters. This is in chapter 8. And in the next chapter, we're still going to be using inferences, but there we're going to be using it to formulate decisions about what the actual population parameter is. So let's see, this is chapter 9. Okay, so what are we going to use to make these assumptions? We're going to have simple random samples of our random variable x of size n. We're going to assume we know sigma. If we don't, we can use S, the population standard deviation, as long as our sample is large enough. So we know the size of our sample n, we know sigma, the population standard deviation, and we're going to assume that our x is normally distributed. Or if our sample size is large enough, that's okay. Then X bar is normally distributed. So we have those three values. What are we going to be doing with that? Well, we're trying to estimate the mean of a population parameter. We're trying to estimate, in this case, the population parameter, the mean, and we're going to have our first guess at it. Our first guess is what we call the point estimate. So for us, we're going to use X bar. So it's usually a pretty good start, but it's not going to be exactly the same. The difference between what we measure, X bar, and what the theoretical value of the population parameter is, that's called our margin of error. And how sure we are of our answer is going to be our confidence level. And we're going to call that C. And so if you're very confident, C is going to be bigger. If you're not so confident, C is going to be smaller. Okay, so what do we have? We have X as random variable. We have a simple random sample of size n. And then we have the value of sigma, the population parameter. And then we're going to say the confidence level that we're given. So how do we actually do this? So the idea is, move this up, we're going to find our ZC depending on what confidence level we are asked about. And remember, now we can use a table. We don't have to calculate this. We can use a table to find this. And then we're going to see what our margin of error is. So our error, which you saw from the warm-up slides, is given by ZC times sigma over the square root of n. So that is Z sub C times the standard deviation of your sample mean. The confidence interval is X, this should be, X bar minus E and X bar plus E. So the idea is that the probability that your mean, that the population mean is actually between these two values is C. The probability that your mean is in this interval is C. So you're 98% sure that the mean is in this interval, for example. So we have to do these 3 steps. You find your ZC, you calculate the error, then you take whatever your sample mean was, and you add and subtract the error from that value. That gives you an interval for x bar, and the actual mean mu is in there somewhere. How sure am I? I'm C sure. We will look at a full example in the next video. So in this case, we're given a confidence level, and we want to find an interval for mu. The other kind of question you could be asked is to find the sample size. So how to find the sample size that is appropriate. So sometimes we want to set in advance the confidence level and the maximum margin of error we would like. So we're asked to figure out what would be the appropriate sample size. Well, we saw in the slide above that ZC is x bar minus mu over sigma divided by the square root of n. This whole thing, well, we then got that ZC times sigma over the square root of n is x minus mu. This is what we were calling E. Okay, so we have ZC times sigma over square root of n equals E. What are we looking for in this blue box on the left side? N. We're trying to solve for n. So you just solve this equation for n, and you get the one that's in the box. So let's, for example, you would have sigma over the square root of n is E times ZC. Oops, excuse me. Let me go back one, try to erase it. E divided by ZC. And so now I flip both of my fractions, and I get the square root of n over sigma is ZC over E. And then to get the equation in the box, you multiply both sides by sigma. The square root of n equals ZC over E times sigma. And then, of course, you have to square both sides. So we end up with this. So that's how we get that. So you don't need to know that derivation, just need to know this formula in this box over here. Just notice, however, that n is the sample size. So you can take 3 items from the population, you can take 17 items from the population, you can take 20 items from the population, you can take 21 items from the population, but you cannot take 21.3 items. Right? You can't take half of a measurement or a part of a measurement. So what are we going to do? If your n is not a whole number, you're going to bump it up to the next integer, always up. Okay, so that's the bit of the theory. The next video will show you an example worked all the way out, dealing with both of these questions, finding the confidence interval and finding the appropriate sample size if you're interested in a particular confidence level and margin of error.